Hi everyone. Now that you've seen all the factoring techniques, today I'd like to look at knowing when to use which technique. So, for today's subtitle, please put down knowing which technique to use. Now, keep in mind that this is only a recommendation. This is what I like to do. You as an individual, as you gain more experience with factoring, you will learn to develop your own rhythm and your own style. So, what do I like to do? Well, when faced with a problem, the very first thing I look out for is the following. Is it a polynomial with 4 terms? If it is, there's no argument. I'm going to use a grouping technique. So let's put that one down first. If it's a polynomial with 4 terms, put down grouping technique. Here's an example of what a polynomial with 4 terms looks like. Put example and put the following: 2x squared y plus 3x squared plus 10y plus 15. And through the grouping technique, you should find that when you factor this, it produces the result of x squared plus 5 multiplied by 2y plus 3. So a polynomial with 4 terms is very easy to detect. Now, what's the next thing I personally look out for? Well, I look out for, is the polynomial a binomial? Or more specifically, is it a binomial in which it's a difference of perfect squares? So let's put that one down. Is it a binomial? And to be specific, is it a difference of squares? If it is, then the best and the fastest technique is to use the difference of squares technique. So, here's an example of what I'm looking for. Put EX, please. So suppose I had something like this: 4x squared minus 25. Well, it's a very easy detection process. It is a difference, and the 2 terms are both perfect squares. So the difference of squares technique is very, very quick. It produces 2 conjugates, one being the square root of the first term, 2x, plus the square root of the second term, 5, and the second bracket, same results, except it's a subtraction. Again, a very fast technique and very convenient if the binomial happens to be a difference of squares. Alright, next, what do I tend to look out for? I look out for if the expressions are trinomial. But not just any trinomial, specifically of the form something x squared plus something x plus a number. If I see something like that, then I personally jump right away to the product sum technique. Very, very fast technique, and as you've practiced in the past, it's a little puzzle trying to figure out sometimes what are the combination of 2 numbers for the product sum to work. Now, when it comes to trinomials of the form something x squared plus something x plus c, well, for those of you who are skilled at being able to detect a perfect square trinomial, Well, then you can apply the very, very convenient technique called the perfect square trinomial technique. So, let's look at an example of what I'm on the lookout for. Suppose I give you the following example. X squared minus 14x plus 49. So like I mentioned, whenever I see a trinomial of the form something x squared, something x, and no x, I usually jump right away to the product sum technique. For this particular example, the product turns out to be 49, and the sum turns out to be minus 14. The two numbers that work are minus 7 and minus 7. So therefore, using the product sum technique, this becomes x squared minus 7x minus 7x plus 49. Now you have four terms, so right away I'm going to use grouping technique. So that's going to become x multiplied by x minus 7, and over here I'm going to take out the negative 7, leaving behind an x and a negative 7, and finish up using the common factor technique, x minus 7 multiplied by x minus 7. So it's very nice with the product sum, but if you are skilled at noticing that this trinomial was in fact a perfect square trinomial, then you could have done this right away. Perfect square trinomial technique is very, very quick. It comes from a binomial being squared, and in the bracket you square root the first term, square root the third term, and you take the sign of the middle term. Notice that these two are the same. Now, there's one technique that I haven't mentioned yet, the common factor technique. Why I saved this one till last, because in fact the common factor technique should be a technique which can be used at any stage of your work. You should always be in the mindset of looking for when the common factor technique can be used. So let's put that down. Put down the common factor technique should be used at any stage and at every opportunity. So let's do a couple of examples, and you'll get the rhythm for the thought process that I personally go through. Let's put an example. So suppose I give you a very, very vague question, factor the following expression: 4x cubed minus 4x squared minus 8x. Alright, let's look at my thought process. Well, it's not a polynomial with four terms, so grouping technique is out. It's not a binomial, so difference of perfect squares technique doesn't apply. And it's a trinomial, but it's not a trinomial of the form something x squared, something x, and no x. This is a third degree trinomial. So we can't exactly use the product sum technique yet either. However, always look for an opportunity to use the common factor technique, and in this case, there actually is a common factor. So let's use the common factor technique first. So the common factor for all three terms is the following: 4x. So I'm going to pull that out, and what's left over inside the bracket? I have an x squared minus x minus 2. Ah, interesting. Look at what that reveals now. The bracket has suddenly become a trinomial of the form x squared something x and no x. So for the bracket, we can use our product sum technique. So let's take a look. The product is minus 2, and our sum is minus 1. It looks like the combination of our two numbers is positive 1 and negative 2. Excellent. Alright, so let's apply our product sum technique. The 4x is always there. I'm going to put square brackets to limit my workspace. And let's apply the product sum technique. X squared plus 1x minus 2x minus 2. Let's keep going. 4x. Let's do our grouping technique now. That becomes x multiplied by x plus 1. Take out the 2. That's going to give me another x plus 1. And let's finish up the bracket. 4x, common factor technique, x plus 1 and x minus 2. And there we have it. In one question, I believe we used common factor technique at least twice, and we used the grouping technique once. Alright, I think it's time for you guys to try one on your own. For example, why don't you try factoring this one and see how it works out for you. Factor x to the 4 minus 16. I'd like you to pause the video and give it a shot. Alright, let's see how you guys did. Well, it's not a trinomial, so I can't use any of the trinomial techniques, but it is a binomial. Is it a perfect difference of perfect square binomial though? It is. There's a difference, and both terms are perfect squares. So, I'm going to apply the difference of perfect squares technique. So that'll give me the two conjugates, x squared in both, 4 in both, and one bracket is a plus, the other bracket is a minus. Alright, so it looks like we might be done, but you need to train your eyes to realize that the second bracket actually represents another binomial, specifically a difference of two perfect squares. So I'm going to apply the difference of perfect squares technique one more time. X squared plus 4 multiplied by two conjugates. One is x, the other one is 2, and plus minus. And now we're done. So this is how we factor any given problem. Again, I'd like to repeat that you as an individual will eventually, with practice, develop your own rhythm and your own techniques and your own preferences. This is what works for me. I'll see you guys in class tomorrow.